All right, this is the fifth FRQ from the 2019 AB exam. So the first thing they want us to do is find the area of R. And we have two functions. We have to recognize which one's on the top, which one's on the bottom. So when I looked at this, I saw this is an upside down parabola. So that's h of x. That makes this g of x. And so if I do top minus bottom, then I have from 0 to 2, and I've got h of x minus g of x. So 6 minus 2 times x minus 1 squared minus negative 2 plus 3 cos. So I've got 6. Now you can do this a few different ways, and when I did it, I did u substitution. I separated this into 3 integrals basically, and I put the plain numbers together, and then I did u substitution, and then I did u substitution again. But I feel like that was kind of messy, and I didn't really love it. So I'm going to go ahead and do it a little bit differently here. X minus 1 squared would be x squared minus 2x plus 1. So I've got 8 minus 2x squared plus 4x minus 2. And so when I do that, I end up getting 6. I guess I can put it in order. Negative 2x squared plus 4x plus 6 minus, and I'll say dx. Yeah, dx minus 3. Okay, so this way, all I have to do is use u substitution over here, and so that'll save me a little bit of effort. So I've got negative 2/3 x to the third plus 2x squared plus 6x. And then over here, I'm going to do u substitution. So if I plug 2 in, I get pi halves times 2, which is pi. If I plug 0 in, I get 0. So from 0 to pi cos u. Okay. Antiderivative of cos is sine. So 8 times 2, I've got negative 16/3 plus 4 times 2 is 8 plus 12. And then I've got minus 6 over pi times sine pi minus sine 0. Sine of pi is 0, sine of 0 is 0, so that just goes away. So I've got 20 minus 16/3. And again, honestly, I really should leave it here and call it good, but I just feel like I gotta finish it. So 60/3 minus 16/3 is going to be 44/3. All right. Part B says that the region R is the base of the solid. It says you have your cross sections perpendicular to the x-axis. That means that they're in terms of x. And so that means that I've got from 0 to 2. And it's in terms of x. Now, normally if they said the cross-section were like squares or something, we would figure out what s equals. It would equal top minus bottom, h of x minus g of x. And then if they said squares, we would do s squared. If they said something about a rectangle, we would do that area, all the different things. But here, they tell you what the area is, which might throw you off a little bit because they've never done that before. Typically, they tell you what the information, and you find the s, and then you do the work. So here you don't have to do that. You just say, okay, the area is 1 over x plus 3 dx is that height. And so, or perpendicular, I guess this is width. So perpendicular to the x-axis, that means that your areas are like this. I'm drawing circles, but they're not really circles. And then your change here, what you're adding, your dx is this part right here. So this is all you have to do. So what you end up getting is you have ln, I almost wrote lin. You have ln of x plus 3 evaluated from 0 to 2, which is ln 5 minus ln 3, and you can call it that, or you can say ln 5/3. Both of those answers are good. So that one was only tricky in that you had to understand how to do it in like a different context than we typically do, or just phrase differently, I guess, than we typically do. So they're being a little tricky there. Okay, next we're going to write an integral expression but not evaluate it. So they want you to have the horizontal line y equals 6. So 1, 2, 3, 4, 5, 6 is right here. This is what we're rotating around. There's definitely going to be some white space there, which means that we're using the washer method. So we've got capital R, so your big radius is going to be top minus bottom, and it's the furthest radius. So 6 minus g of x. And then your little r is top, sorry, you can see that, top minus bottom again, so 6 minus h of x. All right, so we're going to do pi big R squared minus little r squared. And then that's all you had to do was set it up. You didn't actually have to solve anything, thank goodness.